You watched Interstellar, and if you're like most people, you cried at the ending. But while you were wiping your eyes, you missed the biggest twist in the whole movie. Because most of what looked like science fiction on that screen is real, tested, Nobel Prize level physics. And the one detail that everybody calls movie magic turned out to be the most real thing in the entire film. So today we're going through Interstellar like detectives, scene by scene, and on every scene we put a verdict, real or fiction. The black hole, the time trick, the mountain-sized waves, the wormhole, the frozen clouds, the tesseract at the end, all of it. And we can actually do this because behind this movie stands Kip Thorne, a physicist who checked every single frame against Einstein's equations and later won the Nobel Prize. By the end, you'll know exactly which parts were pure science and which parts Nolan simply invented. And I promise you, the answer is backwards from what you think. Miss this, and you'll keep calling real physics special effects for the rest of your life. Let's start with the star of the movie, and I don't mean McConaughey. I mean Gargantua, the black hole. Here's what actually happened behind the scenes, and it sounds made up, but every word is documented. In 2013, a visual effects studio in London was ready to draw a black hole the usual Hollywood way, which means an artist makes something scary and dark and everyone moves on. But instead of concept art, Kip Thorne sent them pages of equations, Einstein's actual equations for a spinning black hole, and said, "Don't draw it, calculate it." So the studio wrote a new piece of software just to solve those equations, and they fed it so much data that the final renders took up about 800 terabytes. And then something strange happened. When the first image came out of the computer, there was a glowing ring of light wrapped over the top of the black hole and under the bottom, like a halo bent around a sphere. The artists thought their code was broken. So they called Thorne, and Thorne checked the math and told them the code was fine. That's what a black hole actually does. Its gravity is so strong that it bends light around itself, so you literally see the glowing disk that's hiding behind the hole, folded over the top and bottom like light going around a funhouse mirror. It's called gravitational lensing, and it was sitting in Einstein's equations for 100 years, waiting for someone to render it properly. And here's the part I love. The images were so scientifically new that they didn't just go into the movie, they went into a real physics journal. A Hollywood blockbuster produced an actual peer-reviewed science paper about how spinning black holes bend light. Verdict on Gargantua: real. As real as it gets. But an accurate picture is one thing. The movie also claims something far crazier. That near this monster, time itself slows down, and 1 hour on a nearby planet equals 7 years on Earth. That sounds like pure fantasy, except the proof that it's real is sitting in your pocket right now. Here's the idea, and it's the deepest thing Einstein ever discovered. Gravity is not really a force pulling on you. Gravity is heavy objects bending space and time around themselves. And when time gets bent, it runs at different speeds in different places. The stronger the gravity around you, the slower your clock ticks compared to someone far away. Not your feelings, not your perception, the actual physical time. Miller's planet sits right next to Gargantua, deep inside its gravity, so time there crawls. 1 hour on the surface, 7 years back on Earth. And that number is not something a screenwriter pulled out of the air, because Nolan gave it to Thorne like homework, and Thorne went off and calculated what it would take. His answer? It works, but only if Gargantua is spinning at 99.8% of the maximum speed a black hole can possibly spin. Extreme, but allowed. The equations said yes. Now, the pocket proof. Your phone finds you on a map using GPS satellites, and those satellites carry atomic clocks. Because they sit high above Earth where gravity is weaker, their clocks run faster than clocks on the ground by exactly the amount Einstein predicted, about 45 millionths of a second per day, minus a small speed effect for a net 38 microseconds daily. Sounds tiny, right? But if engineers didn't correct for it, Your GPS position would drift by about 10 kilometers every single day, and by the end of the week, your phone would think you live in a different city. So every time your Maps app finds you standing in the right parking lot, that is general relativity working, the same physics that slows time on Miller's planet. Verdict: real, and you use it every day without knowing. So fine, the time trick is real. But then the crew lands on that planet, and a wave the size of a mountain range comes for them. And this is the scene where most people say the movie went too far. Most people are wrong. You already know this force, you just know it's small. The moon pulls on Earth's oceans and gives us tides. The water rises maybe a meter or two. Now replace the moon with a black hole 100 million times heavier than the sun and put the planet right next to it. Gargantua's gravity grabs Miller's planet and stretches it like dough, and all the water on that world gets pulled into two giant bulges on opposite sides of the planet, while everywhere in between stays shallow, which is exactly why the crew lands in water that's only knee-deep. That detail isn't a mistake, it's the physics. Thorne ran the numbers here too, and he got waves around 4,000 feet tall. That's a wall of water higher than most mountains you've ever seen, and it matches what's on screen. The planet slowly rocks back and forth under the black hole's grip, so those two bulges sweep across the surface again and again, like the slowest, biggest waves in the universe. Verdict: real. Built from the same tidal force that moves the ocean outside your window, just turned up 1,000,000 times. But hold on, because we skipped the most important question of the whole movie. Before any of this, how did they even get there? Another galaxy is millions of years of travel away. They took a shortcut, a wormhole. And this is the moment where physics itself starts sweating. Everything I've shown you so far, the black hole, the slow time, the waves, that was the easy part, because all of it sits safely inside physics we can test. But from here on, the movie walks along the very edge of what science allows, and the verdicts get harder and stranger. And the detail from the beginning, the movie magic that turned out to be the most real thing in the film, we're almost there. Don't you dare skip ahead. In 1935, Einstein himself, together with a physicist named Nathan Rosen, found something weird hiding in his own equations. Space-time could form a bridge, a tunnel connecting two faraway places, like folding a piece of paper and punching a hole through both layers. The math allowed it. But there was a catch, because those bridges slam shut faster than anything could ever pass through them. A door that closes before you can blink. Then in 1988, and yes, it's the same Kip Thorne, this man keeps showing up. Thorne and his student Mike Morris asked a new question. Could you hold a wormhole open long enough to fly through it? And the equations answered, yes, but only if you fill it with something physicists call exotic matter. Stuff with negative energy, matter that pushes space apart instead of pulling it together. Here's the twist. Negative energy is not fantasy. In quantum physics, there's a real, measured effect called the Casimir effect, where tiny amounts of it genuinely show up in the lab. Nature has the ingredient. The problem is that you'd need planet-sized amounts of it, and nobody has any idea how to collect more than a whisper. And one more detail that shows how seriously this movie took its homework. In the film, the wormhole isn't a flat hole hanging in space like a doorway. It's a sphere, a crystal ball you fly into. That's straight from the equations. Every movie before drew it wrong, and Interstellar drew it right. Verdict: the math says wormholes are legal, the universe just hasn't shown us one, so call it fiction with a valid passport. But now we come to a planet where the movie finally breaks the rules. And here's what's funny. It's not the scene you'd expect. Dr. Mann's planet, the frozen one, where the ship flies between clouds of solid ice and even lands on one. Looks believable, right? Compared to giant waves and time tricks, frozen clouds feel almost boring. But this is the one scene that Kip Thorne admits makes him cringe, because he checked the strength of ice, and ice simply cannot hold itself up in structures that size. A frozen cloud would snap under its own weight and rain down in seconds. He even tried to rescue the scene with theories about frozen carbon dioxide, and it still didn't work. Think about what that means. The most fantastic-looking scenes in the movie passed the physics exam, and the most ordinary-looking one failed it. Nolan knew and kept the clouds anyway because they were beautiful, the single luxury he allowed himself in a movie built on equations. Verdict: fiction. The only clean violation in the whole film, and the physicists signed off on it with a sigh. One fiction down, but the biggest suspect is still waiting, the ending that broke everyone's brain. Cooper falls into the black hole and lands inside the tesseract, that endless room where he can see his daughter's bedroom across time, where time itself has become a direction you can walk in, and where gravity can carry messages backwards through the years. So where does this stand? Here's the honest answer. There's a serious idea in physics called brain theory, which says our whole universe might be a four-dimensional sheet floating inside a bigger space with more dimensions. Physicists literally call that bigger space the bulk. And in some versions of the theory, gravity is special. It's the one thing that can leak between dimensions, which is exactly why the movie uses gravity and nothing else to send messages. Thorne himself sorted the movie's science into 3 boxes: solid truth, educated guess, and speculation. The black hole and the slow time live in the truth box. The wormhole lives in the educated guess box. The tesseract lives in the speculation box. It doesn't break any known law of physics, but there is zero evidence for it. And the part where love points the way across dimensions, that's not the speculation box anymore. That's just Nolan telling a story. Verdict: speculation wearing a scientist's coat. Allowed to exist, impossible to test. So the scoreboard is almost full, but I still owe you the answer from the very first minute. The detail everyone calls movie magic that's actually the most real thing in the film. It's the very first thing you noticed and the last thing you'd suspect: the look of Gargantua itself. That glowing golden ring bending over and under the black hole. Millions of people watched it and thought, sure, gorgeous Hollywood decoration. And then, 5 years after the movie, in April 2019, scientists from the Event Horizon Telescope pointed 8 radio dishes on 4 continents at a galaxy 55 million light-years away and showed humanity the first real photograph of a black hole. And there it was, the dark shadow, the bright ring of bent light, the same shape the movie had rendered from Einstein's equations. The scientist who led the imaging team said it himself. The picture in Interstellar was almost correct, and Thorne, looking at the real photo, said there were no deviations from general relativity. None. So run the scoreboard with me. The black hole, real. Time running slow, real, and working inside your phone right now. Mountain waves, real. The wormhole, legal on paper, missing in nature. Ice clouds, fiction. The tesseract, speculation. Which means when you watched Interstellar, you weren't watching fiction with some science sprinkled on top. You were watching a prediction, and the universe spent the next 5 years confirming it. You saw a real black hole before humanity ever photographed one. You just didn't know it yet. So the next time someone tells you Interstellar is just a pretty fantasy, you'll know better. You watched real physics disguised as a movie, and now you can never unsee it. Subscribe if you're the kind of person who wants to understand the future before everyone else does. Thanks for watching. Take care, and I'll see you around.